Roya Bahreini, who is in environmental sciences. She's going to tell us about air quality at an environmental justice community of Long Beach. So let me pass that on to Roya.
Great, thank you, David. Thanks very much, Brian. That was lovely to hear, although we, as you said, it's a powerful story and we could sort of feel moments by moments. My talk today, it's not going to be as much of a story, but it's more of results that we collected a few years ago, not too far from Riverside. Let me just share my screen. And thank you, David, and everybody else for organizing the workshop and for the opportunity to speak. Let me just, don't want that. Let's come here and then bring up my pointer. Okay. So I realized as I was putting the slides together that I put too much in the abstract. So I'm not talking about all the things that I included in the abstract, but maybe components of the measurements that are more sort of unusual for an urban environment and maybe are of more concern when it comes to human health. So this was basically collaboration with the South Coast Air Quality Management District for measurements we did in Wilmington. This is basically our measurement site that AQMD had put up, and we were right next to one of the Phillips petrochemical plants in Wilmington, close to Long Beach. So the area of concern is boxed here. This is one of the environmental justice communities that have been identified as part of the Assembly Bill 617. Basically, these are communities that are disproportionately influenced by different sources of pollution. And for Wilmington and Long Beach area, there are a variety of sources. Of course, we have the port of Long Beach and LA to the south and southeast. When you look, all of these sort of gray dots, what it shows as dots on this scale is basically residential areas, but on closer look, you actually realize all these areas that I've circled are either chemical storage plants or chemicals, processing facilities, refineries all along, oil gas fields basically, and then these grayish rooftops that you see are industries and basically distribution facilities. Of course, we have all the major highways ending on the port. So that means there's a lot of traffic going in and out of the ports and a lot of trucks going in and out. So thinking about the interest from California Air Resources Board, as well as the South Coast Air Quality Management Districts, they have identified a variety of different sources, some that they have information on. For example, all these reds are intersections of heavy traffic areas. So we know emissions around there are dominated by mobile sources. There are areas in gray, which are sort of areas that they still need information on. For example, there's a sulfur pile, there is a asphalt making facility, there is concrete and gravel yard basically. So a variety of both chemical industry and manufacturing industry, basically emissions that we and the state does not know much about. Of course, there is the port activities and all the trucking and shipping that comes to the ports. And then there are unfortunately also areas that are right in the middle. As I said, you know, when you drive around, this is just a residential area on one street, and the other side of the street is really like a chemical storage facility. And there are areas that people spend time outside, meaning that the risk for exposure to whatever is coming out of these unknown source areas is pretty high. So we were out there before the pandemic in the fall 2019, and then we went for a short period of time the following fall with the idea of measuring aerosol composition, basically composition of air particles that are suspended in the air. And this is a picture of our inlet and the instrument we had out there to determine if there are unusual components of aerosols that we don't expect from just a plain urban environment. And if we see these components, what are the sources of these? So here's a time series of the major species that we usually measure with the mass spectrometer that I have. At the bottom, we have organics in green, and then inorganics dominated by nitrate and sulfate in blue and red, a little bit of chloride and ammonium that is associated with these. And then on top, we have basically just the variation in temperature and relative humidity. We have the diurnal variation with during the day, humidity going down and temperature going up. In the beginning of the study, we had higher temperatures, daytime temperatures sometimes reaching above 90, and that trend basically decreased. Towards the end, we had cooler, or second half, I should say, we had cooler daytime temperature and cooler nighttime temperatures as well. We have this very contrasting period or two contrasting periods in our sampling project. So in the beginning, we have relatively lower concentrations dominated by organics. And then towards the second half, which was more humid, lower temperatures, we have periods of very high concentrations of inorganics, nitrates and sulfates, associated ammonium, and some organics. So you see with the size of the pie that the concentration is around at least 7 to 10 times higher, and the composition is very different as well. If we think about what wind directions we had, basically, what areas we were influenced by in terms of their emissions, both time periods, we had predominantly northwesterly winds with some contribution from northerly and southeast. So if you remember, basically southeast area is the ports and northwest is more residential and distribution of these chemical facilities and storage tanks and so forth. But as I'll show next, there's also some sort of slushing back and forth of air masses because of onshore, offshore flow that we have because we're at the coastal site, basically. And to complicate things, towards the southwest, we also have the hilly part of Palos Verdes, so that probably induces some strange airflows in the region as well, which makes things difficult. So what did we see in terms of different hours of the day? I think this is important because thinking about when people are exposed to air pollution, if sort of homes are built well, and windows this time of the year probably are not open, the time that they get exposure is mostly when they're outside, right? So that's why time of day sort of consideration of how composition changes can be important. So I've done the averaging for the beginning period when mass concentrations were low, and then contrasting that with the later period when mass concentrations were high. And again, I'm focusing on the major components. Chloride I included just to show its pattern. I had to multiply it by 10 because it's really a small component of the aerosols. What we see during the morning, what you can think of morning rush hour, organics peaked, and during the day it went down. The peak in chloride is about the same time as that of organics, and then nitrate peaks a little bit lower, but both of them go down midday. Sulfate was more or less flat the whole day. This is during the low mass period. But on the other hand, during the high mass concentration time, the second half of the project, organics don't show that strong increase during rush hour. It's maybe more or less flat until mid-afternoon, and then it goes down and comes back up overnight. Nitrate and sulfate and chloride, these inorganics, are peaking up early morning hours. Now, thinking about influence of meteorology and variations in temperature and humidity, of course, because of solar intensity that we get during the day, we get changes in boundary layer height, right? So what we see in these pictures is not just changes in emissions, it's also changes due to now pollutants being sort of during the day with increase in temperature, boundary layer height is deeper, so things are diluted in this larger volume of air. But on top of that, we have this shift in wind direction, right? So during the night, we have mostly winds from the northwest area, and then it shifts over to north, and then it comes to basically southeast part from the port, and then it switches back again to northwest, right? So again, this is what I mean by slushing back and forth. Emissions that go this way at some point could be coming back to us at night. So to get away from the problem of well, this decrease that we see during the day is probably because boundary layer height is the deepest, and so we're diluting some of this pollution. What we can do is actually look at the fraction of these major components, basically the ratios, because the dilution affects all species to the same extent. And what we see is during the early morning hours to midday, contribution of nitrate in aerosols goes up. So there is some net gain of nitrate in the particles, and that's at the cost of decrease in organics. And for the high mass period time, it's actually at night that we have increased contribution of organics, and at the cost of, you know, losing some relative amounts of the inorganics. So for the rest of the presentation, I'm going to focus on a couple of more unusual aerosol components that we've seen, and thinking about what the sources of these could be. So early on in the study, I was actually, so I could remotely check on the instrument, and on a Saturday I saw that sulfate is peaking, and I was worried that, oh, something's wrong with the instrument. But afterwards looked at the data and see that actually it's over several hours that we have an enhancement in sulfate with some strong spikes, and then it goes back to basically background sulfate that we have. So if I look at the average organic mass spectra of the aerosols, we see typically, you know, signal going down with increase in these ion sizes, basically. Except for this time period, we see much higher than background levels of these peaks that are larger in M2Z space, let's say. And these are typical of PAHs. So there is some basically source in the region that not only gives precursors of sulfate, but also it leads to formation of PAHs on the aerosols, or emission of PAHs. Usually these are primary aerosols. So looking at time series of organics in green, and the dots are PAHs, the concentrations are usually nanograms, tens to hundreds of nanograms per cubic meter, but that on its own is still measurable and could be problematic. And you see how nicely it spikes, basically, with spikes in sulfate and this enhanced period of sulfate with that. So how was the wind in this time period? If we look at this, focus on this time period, we actually see the higher sulfates, which also corresponded to higher PAHs, are coming from the southeast period, south and southeast, indicating that there was something on the port. It could be a bad burning ship, basically the emissions from ships that are docked at the port, or other activities at the port that are emitting sulfate precursors as well as PAHs directly. So indeed, this could be problematic for residents that are close to the coast. Then other sort of components of concern are trace metals. And the instrument I have, I confess, and I told AQMD that what I have is not good for detecting trace metals, but we can see some signal. We just can't quantify them because we don't evaporate them completely. And during that period I just showed with increased PAHs, we also see increase in nickel. Throughout the rest, maybe there is sometimes that concentration goes up, but not as much as this beginning time, basically. And then some of the other metals that we saw some changes in their profiles are zinc and titanium here. So if I start blocking periods off, we see that this time that nickel went up significantly with PAHs, and sulfate, we also have some zinc and titanium. But then towards the end, we have increase in zinc, titanium, and magnesium, which is unusual because magnesium, you always think either, okay, marine source, but not this significantly, but also it could be coming from earth components, basically. These are, they could be part of natural sort of crustal components. And then we have nice correlations between manganese and aluminum. Again, aluminum could be very much from crustal elements, but manganese could have industrial emissions too. In terms of correlations of these with the major aerosol species, the highest correlation was with sulfate for zinc and titanium with R² greater than 0.8. So again, there are common sources of major aerosol components and trace components that could be tied to unusual activities specific for this site. So next, I looked at basically correlations or cross correlations between pHs, zinc as an element of concern, and manganese, another element of concern. And we see different populations. Basically, there is some source that is emitting zinc, low in manganese with emissions of certain levels of pHs, not much, maybe 20, 30 nanograms per cubic meter. And then we have another source that gives a lot more manganese, much less zinc, but could have a lot higher pH emissions too. So I guess long story short, the measurements, because it was at one station for, let's say, a month, it indicated the concerns or confirmed the concerns of the community and sort of highlighted some of the areas that are more of concern, basically the port areas and perhaps these chemical plants to the north, but we don't have a solid sort of understanding or certain understanding of what the exact sources are. And again, understanding this on a, when you have area sources spread and shifting the wind direction, it makes things difficult. Plus, towards the end of the campaign, with temperatures at night being low, we cannot sort of rule out the potential of local residents burning some fuel just for heating that is not of good quality. Because as you saw in the high mass period times, organics goes up at night. And so that is usually related to combustion of fuel, right? And these trace metals could be coming if that fuel is not of high quality. All of this, basically, I'm not going to read through the conclusions, but we have some cross correlations between trace metals, pHs, and sulfate precursors. We don't know where the exact sources are. But this basically motivated AQMD to write a proposal to EPA. So I'm one of the co-PIs on this NSF-funded project to establish 12 sites around the US for continuous and fast time resolution measurements of aerosol composition and size distributions, basically. We have a site in close to UCR in Rubidoux. We have another site in California and Pico Rivera downtown. And really going somewhere closer to the coast, it would have been ideal, but with budget that we had 12 million for NSF, we just couldn't put every site of interest. We couldn't develop it into a network like that. So AQMD is now, it now has a proposal with EPA to consider to establish something similar to this at the Wilmington site. And then probably they can augment that with their mobile measurements or you know, other measurements in the area to really get to the bottom of what these point sources could be that are problematic and hopefully do something about it. I think with that, I'm probably over my time limit, so I'm just going to I'll be happy to take any questions.
Okay. Thanks, Roya. No, you were just on time. Let me ask a question. You call it an environmental justice community, and I don't think everybody knows what that means and what it could mean in terms of the community's power to get policy or action. What does that all mean with being an environmental justice community?
I'll do my best, and feel free to I know you're also very much involved with the EJ community. So basically, these are communities that unfortunately are not economically well off, but at the same time, they have in their neighborhoods sources of pollution that, of course, impacts them most because they're the closest to these sources. And so what AQMD and Air Resources Board are doing are identifying these communities and holding meetings to hear the concerns of the communities and try to do what they can in terms of doing measurements like this or some measurements on their own, basically with their own staff and instruments that they have to identify the polluters and try to see what can be done for limiting their emissions, basically. From my understanding, AQMD has jurisdiction over, for example, point sources, not mobile sources, right? So that's why in this area, for example, there are a lot of point sources they've identified that they don't have enough information of what they're emitting. What complicates this work is industry does not necessarily have continuous emissions of their problematic pollutants, right? The their emissions can be episodic. So what AQMD and other air quality districts need to do is to have continuous measurements, but be able to capture these spikes that could be just for 1 hour, right? Right now, their monitoring networks collect, for example, aerosol composition or filters to go and analyze basically for aerosol composition. And they do this every 3 days or every 5 days, right? And their measurement is integrated over 24 hours. So something like that for a community level sort of understanding of the sources is not enough. So that's why they're basically expanding their network and trying to do more unique measurements in these communities of interest to really get to the bottom of these. Well, I shouldn't say unregulated. I think there are still, for example, for lead, there are, the NAC standard is there. But for these trace metals, I don't think there are regulations that emissions or concentrations should be below a certain amount, but it's still good to know what these concentrations are and try to work with the industry to reduce that. I don't know if that answered your question.
Well, so, you know, you have the refineries, you have the port, you know, so there are a lot of different sources, but
Yes.
so the question is like, when the scope of the monitoring you're doing, can that actually help extend the geographic definition of who are the affected communities?
Yes, if it has also other components. So sitting in one location, I don't think is enough. A lot of these sites, I think, to understand the emissions, you need to have a measurement upwind and downwind, right? Because there are so many things distributed. Now, if you want to just know exposure in one community, then yes, one sensor would be either mine or one of their own instruments would be fine to see if you're in that community, what the exposure is. But to take it to one step further and say what the actual sources are, I think you need more measurements, either a network of these or at least a mobile measurements that you can go back and forth. But again, with mobile measurements and sort of sporadic emissions that you have, that's also difficult.
Okay, thank you. Let's move on then, I guess. Thank you, Roya.